Bismillahirrahmanirrahim. In this session, we will discuss diffraction of waves, the diffraction through a narrow gap. In a figure 3.1, 10a and 10b, straight water waves in a ripple tanks are meeting gaps formed by obstacles. So this is obstacles, and in figure 3.1, 10a, the gap is narrow. The gap is so close and is very narrow, very small gap, and a wavefront curves around the edges of the gap produces a circular wavefront. So it produces a circular wavefront, whereas the gap in the second one, we have a larger gap. The spreading of wave after passing through a wider gap. So in a wider gap, we will see it's a different one. Diffraction due to an edge or a wide gap. In figure 3.10b, the gap is wide, 10 cm compared with the wavelength, and wavefront remains straight, except at the edges of the gap where some curvature around the edges occurs. Some curvatures occurs. So at this end, some curvatures occurs. Some bending occurs at the edges. Where some curvature around the edges occurs, the spreading of wave at the edges of the obstacle is called diffraction. That spreading or that obstacles creates this bending, this spreading of wave at the edges of the obstacle is called diffraction. Spreading of wave. The waves is changing its shape or is bending or bending. So when design harbors, engineers use model like that in figure 3.111 to study it. This is the phenomena that this gap is used in a harbor or boats are developed. So this kind of studies are used. Diffraction phenomena are applicable in this one. In everywhere where this is the one of the application, and the model of a harbor used to study wave behavior. So this wave behavior diffraction is used. So for a narrow front produces circular wave front, but this larger gap produces, wide gap produces straight, except some bending on the edges. So this diffraction phenomena used to develop these harbors, this kind of harbors, designing harbors. Test yourself is one of the problems. So one side of the ripple tank ABCD is raised slightly and ripple is started. And ripple is started at P by a finger. After 1 second, the shape of the ripple is as shown. The shape is changed. So it shows that why it is not circular. So this should be circular. Rather than circular, it's an elliptical shape. In a shallow region, the wavelength gets shorter and the wavefront gets closer, while in a deeper water region, wavelength increases and wavefront expands slowly. Therefore, it is not circular. So in this region, so if we incline it slightly, make an angle with this, so make it deep region water and a shallow region water here in this region. So in this kind of shape is produced. So this is one of the reasons that we discussed. In the shallow region, wavelength gets shorter and a wavefront gets closer. In the deep region, and wavefront gets closer, while in the deep region, wavelength increases and wavefront expands accordingly. So wavefront expands in a deep region and closer in the shallow region. So that's why this shape has transformed from circular to elliptical one. So which side of the tank has been raised? Side AB has been raised. So this becomes a shallow region. This gives a shallow water region, whereas CD becomes a deep water region. Now 3, the angle of incidence of a ray at a plane reflecting surface is 35 degree, what will be the angle of reflection? Same, it will have the same angle of reflection, 35 degree in this case. During the refraction of a wave, which of the following properties does not change? The speed, the frequency, the wavelength, the direction of travel. The frequency does not change. The frequency remains the same, and speed and wavelength changes, and direction of travel is also changes because of the reflection. It bends toward the bends away from the normal, so direction also changes. So only B is remains constant, so it does not change. So that's why the answer B is correct. When a wave passes through a narrow gap, which of the following terms best describe what occurs? Diffraction, as we studied. So in the next session we will discuss